Alrighty, section 5.3, add, subtract, and multiply polynomials. So first of all, try these out. See if you remember how to do that. The multiplying, this is kind of what you were doing in 5.2. This is simplifying or putting in the right order. So give it a try. And when you come back, check your answers. Okay, here you go. All I did here was, this is really all just multiply. Parentheses just mean multiply, so I kind of reordered it and ended up with negative 15x to the fourth. This is common terms, so you just subtract. This I reordered and I saw that these two were common terms, so I subtracted them and I have 2y squared plus 7y minus 1. This you had to distribute, and you end up with this when you combine like terms. Alright, and then here they asked for the perimeter. Well, in a square, if this is one side, there's 4 of them, so 4 times 2x plus 5 gives you 8x plus 20. Alright, so let's have some fun here. Add the expression to the format given. So what they want you to do, add the expression in the format given. Sorry about that. They want you to add this polynomial and this polynomial in a vertical format. So like this. So I'm going to line this up underneath its common term here, or like term. So negative 5x cubed minus 2x squared minus 4x minus 4. And remember, I'm adding them. So I'm just going to add down. 10 take away 4 is 6. Put a plus sign in front of there. Negative 3x plus negative 4x is negative 7x. 4x squared, take away 2x squared. I have 2x squared. And then 4x cubed, take away 5x cubed. This is going to be a plus in front of here. If you can look there, it's a plus. And then 4x cubed, take away 5x cubed is a negative 1x cubed. And so there you go. You added those polynomials together. All right, let's do this again. Horizontal is a little bit different. Okay, so horizontal means you just kind of add them straight across. So what I did was I took and I combined the terms that were alike and put them next to each other. So I had a positive 2x cubed and a positive 3x cubed. You don't really have to write this all out. If you can just imagine that this is a plus sign here, and then just combine like terms. So here now I have 5x cubed. Those are done. And then I have 2x squared minus 4x squared. That gives me a negative 2x squared. Negative 3x, take away another x, that gives me minus 4x. And then 5 plus negative 7 is minus 2. So there we go. All right, subtract the expression in the format given. So here I need to do a vertical. So I need to take this polynomial from this polynomial. So I'm going to subtract this one from this one. So I'm just going to rewrite it underneath, lining up the like terms. Now, because I'm subtracting, the easiest way to do that is just change it to an add and change all these to their opposite. So I'm going to change this to a plus and change these all to their opposite signs. And then I can just add down. It'll be a lot easier that way. So 3x cubed plus 4x cubed is 7x cubed plus, this will give me negative 2x squared plus negative 2x plus 15. Now, of course, you can go ahead and write those right as minuses. It doesn't matter to me how you write it. Okay, horizontal. So again, we're going to take this away from this. So I'm going to put a subtract here. I'm going to put this in parentheses. 6y squared minus 6y minus 13. I'm subtracting this polynomial from this. So again, if I change this to an add and change these all to their opposites, then I can just combine like terms. Oh, sorry about that. You couldn't see that for a second. So I'm not working with that right now. So I'm working with 3y squared plus negative 6y squared. So when I combine those two, I have negative 3y squared. Then I have negative 4y plus 6y. So I have plus 2y. Those are gone. And then I have 7 plus 13, which is plus 20. And that's my answer there. Okay? All right, now we're going to do multiply. Multiply the expression in the format given. So I need to multiply this and this. I'm going to take the binomial and I'm going to write it right underneath. And this is kind of just like multiplying numbers, actually. So what I'm going to do is I'm going to multiply this term by everything that's up here. 3 times 5 is 15. I'm going to write that down. It's a plus. 3 times 3x is 9x. And that's also positive, so I'm going to put the plus in front of there. And then 3 times 3x squared is 9x squared. Okay, the same thing when you multiply numbers by hand. I'm moving over here a spot, so I got to put a 0 here. And then put a plus here. And I got 2x times 5 is 10x. That's a positive. 2x times 3x is 6x squared. And then 2x times 3x squared, this is tight, sorry, is 6x cubed. Okay, and then I'm just going to add down like you would if you were multiplying a number. So 15 plus 0 is 15. 9x plus 10x is 19x. 9x squared plus 6x squared is 15x squared. Plus 6x cubed. And there you go. Okay, and you can also multiply in vertical. So what I'm going to do is I'm going to take this, I'm going to multiply it by this, but the easiest way is to split this binomial up and write it like this. X squared minus 2x plus 3. I'm going to multiply it by the first term of that binomial. And then I'm going to take that first trinomial and multiply it by the second term of that binomial. So here is the x minus 5. And if you combine what you get here with what you get here, it's the multiplication or the product of those two. So I'm going to distribute that x to each of these. And I get x cubed minus 2x squared plus 3x. And then I'm going to add to that negative 5x squared plus 10x minus 15. Then I got to take a look across and combine like terms. There is no other x cubed, so that's going to be part of my answer. I'll cross that off. There's a negative 2x squared plus a negative 5x squared, which is a minus 7x squared. Cross those off. Plus 13x. Cross those off. And minus 15. And then that would be the product of those two polynomials. Okay. Now what I need to do is I need to multiply x minus 1, and x plus 2 in first the horizontal format and then in the vertical format. So the first thing I'm going to do is multiply those two together. Basically it looks like this, x minus 1 times x minus 1. You can use the FOIL method. It's also a special product or square of a binomial, if you remember that, which we'll get into again here. But I just know that this is going to be x squared minus 2x plus 1. And you can FOIL it if you need to. Okay, so I multiplied the first two together, and then I got to multiply it by the third binomial. Now this is just like we did on the other side. And you can split it up like we did on the other side. Or you can just say to yourself, all right, I know I got to multiply x times everything in here and add to it 2 times everything in this one. So that's what I'm going to do this time. I'm going to do the x first. So I have x times x squared, which is x cubed. X times negative 2x, which is negative 2x squared. And x times positive 1, which would be plus x. And then I'm going to add to that 2 times x squared, which is 2x squared. 2 times negative 2x, which is minus 4x, and 2 times 1, which is 2. And then just combine like terms. So x cubed is by itself. I have negative 2x squared and positive 2x squared. They cancel each other out. And then I have 1x, take away 4x, I got minus 3x plus 2. And that is all three of those binomials multiplied together. Then the vertical format. Well, for the vertical format, you still have to multiply those first two together and end up with this. And then multiply it by the third binomial, just like we did on the other side. So I'm going to do 2 times 1, which is 2. That's a positive. 2 times negative 2x is negative 4x. I'm going to write it like that. And then 2 times x squared, which is 2x squared. Okay, and then I'm going to hold this spot because I'm moving over here. And x times 1 is just x. And then x times negative 2x. This is a positive x. X times 1 is a positive x. And then x times negative 2x is negative 2x squared. And then x times x squared is a positive x cubed. So I'm just going to write x cubed here. And then add them down. So you have 2 minus 3x. These two cancel each other out. And you have x cubed still. So x cubed minus 3x plus 2. Same answer. Would you look at that? That's kind of cool. All right, special product patterns. I know you've seen them at some point, and you're going to be using them a little bit. Do you necessarily have to memorize them? They're very helpful if you memorize, especially these. The cube of a binomial, yeah, but to be honest with you, you don't need to completely memorize it, but it is really helpful. So we're just going to exactly follow the patterns that are up here and multiply these, find the product of these. So here you can see this is a sum and difference. The terms are the same in the two binomials, but this is a minus and this is a plus. So I'm going to end up exactly with what it says here. A squared, A is 5y, and B is 3. Not negative 3, just 3. Okay? If I have that instance like I do here, then I'm going to end up with a squared, which is 5y squared, which is 25y squared, minus b squared. B is 3, so 3 squared is 9. There's my answer, if I follow this pattern right here. All right, here is the square of a binomial. It's 4a plus 7 times 4a plus 7. It's the same special pattern right here. And this says, okay, if you look at this as A and this as B, then you just follow exactly this pattern here. So it says to square A, so I have 16a squared plus 2 times my A times my B plus b squared, which is 49. And then I simplify this middle term to get my answer. 16a squared plus 56a plus 49. Very easy. If you don't remember the pattern, you could always FOIL. Okay? Here is another, this is a cube of a binomial. It's a minus. So you notice here, this is the pattern they're saying. Okay, you're going to have a cubed minus the 3a squared times b plus 3a times b squared minus b cubed. So let's just follow that pattern. Here our a is mn and our b is 6. So let's just follow the pattern. We have a cubed, so I'm going to write mn cubed minus 3 times a squared, which is mn squared, times b, which is 6, plus 3 times a, which is mn, times b squared, which is 6 squared, minus b cubed, which is minus 6 cubed. And then we just have to make it pretty. So we learned yesterday that we can distribute that 3 on both of the terms within here. So we're going to have m cubed n cubed minus this middle term here. We have 3 times 6, so minus 18 m squared n squared. That's that term right there. Plus 3 times 6 squared, which would be 3 times 36, which is 108 mn, minus 6 cubed, which is 216. So that's that. This you would do exactly the same way, except it's all plus across, because it's a cube of a binomial that's a plus. So you would just do it the same way. Realize that this is A and 4 is B. And just follow the pattern up there. Okay, so we wouldn't have any fun if we didn't do a story problem. So new highway markers are placed every 6x minus 6 feet along a stretch of highway. The total number of markers is represented by this right here, this trinomial. Write a model for the distance along the highway where the markers are placed. That means I have to come up with a function or an equation. All right, and then the second thing it says is if the markers are placed every 528 feet, what length of highway received new markers? So the first thing I need to know is that every 6x minus 6 feet was a marker, and the total number of markers is this. So I want to find out the total distance, which means I have to multiply this times this to find the total distance. And you have options. You can do it vertical or horizontal. I think I'm going to set it up vertical. Okay? If you go through the motions, you're going to end up, I'm not going to take the time to do that, but if you go through the motions, just like we did up here and on the other side, you would end up with this 6x cubed minus 24x squared plus 24x minus 6. So this is a model that represents the distance along the highway where the markers were placed. Because that's the first thing I had to do. Then it says if the markers are placed every 528 feet, what length of highway received new markers? Well, I got to find out what x is, and I can plug it into this equation to find the length of the highway that received new markers. So they're saying that 6x minus 6 is 528. They're telling me that right there. So I got to solve for x. And x equals 89. So to find out how long of a piece of highway new markers were placed, I would take x equals 89 and plug it into here. 6 times 89 cubed minus 2489 squared plus 24 times 89 minus 6. When I do that math, I get this. Very big number. 4,039,710 feet. And just for the heck of it, if we divide it by 5,280 feet, because that's how many feet are in a mile, we find out that we have 765.5 miles. That's a lot of miles that were placed with new markers. Isn't that fun?